Hello and welcome. This is 3.1 one-step equations. This is our extra example problems assignment. So please go ahead and label this in the example section for 3.1 one-step equations. This again is the extra example problems. Please also add your name to this and we will staple it to our assignment that we had done previously. The next thing we're going to do is we're going to take a look at our assignment that we took yesterday, and we're going to kind of organize what that might look like, because we're going to use a couple of pieces today about those fraction operations that we were reviewing. So let's go ahead and take a look at that. So please turn to the back side of our 3.1 one-step equation solving worksheet that we were working on last class. And here we're going to indicate the vocabulary we have for a balanced equation. So what you do to one side, you have to do to the other side of the equal sign. And the key concepts for reminders about fractions. So adding and subtracting fractions, we are required to create common denominators if the denominator is not there. So I do want to recall that a denominator is the bottom of the fraction. So if I have a fraction 4 over 5 and I add 6/10 to that fraction, I need to make this a common fraction or common denominator. The 5 and the 10 need to be the same. Now in this situation what I have is I have an interesting idea, since I picked a fraction that normally we cannot do this, where we can divide a fraction evenly. So I can reduce this fraction, not by 3 rather, but I can reduce it by 2, and I can get there. That would give me 4/5 plus 3/5, and I all of a sudden would have common denominators. So other situations in which we might have fractions and need them to be common denominators could include, so we might have another situation that could look like, maybe I'm subtracting fractions and I'm subtracting 9/11 and I subtract 3/7 from it. Here I need to have common denominators among the 11 and the 7. So in this case, I would need to multiply by each term. So here I need to multiply by 11 on the numerator and denominator. And here I would need to multiply by 7 on the numerator and denominator, giving me the idea of 63 over 77, subtracting 33 over 77. My common denominator in this situation here is this. So now on our 3.1 one-step equation extra example sheet, let's give a couple of extra examples. So the first example is this x plus 3/4 equals 6. So I need to look at this and identify, we're using the steps that we had from last week. So can I simplify either side? The other section, so my next idea or my next step is to identify the current operation, then identify its inverse, and go ahead and make that solving happen. So here there is nothing I can simplify, and I need to work on the identification of what the current operation is. So the original operation is addition, so I'm going to want to subtract both sides. And I'm going to want to subtract the 3/4 from both sides. So as I do this, I find that the 3/4 and the negative 3/4 cancel. And I can go ahead and take 3/4 away from 6 and end up with x is equal to 5 and 1/4. Now, if that's not clear for you, we can discuss how to organize that. Here we're talking about the mixed number of 6 and the proper fraction of 3/4. So We can discuss that in class if you're not sure how that works. Moving ahead to the check, when I check this equation, we write the original equation back at x plus 3/4 equals 6. And then we're going to, instead of solve, we're going to do a substitution. And we're going to substitute 5 1/4 into this equation. And I notice that I have an LCD I need to work with here. So my LCD here is 4. And I do want to combine these terms together, so 5 1/4 and 3/4. So in this case, we can use method 2 from our note sheet on the fraction addition for mixed numbers. And I can say that I am adding the 5 plus the 0. Let's go ahead and show this really quickly. So this could look like the 5 plus the 0 because there's no whole number here. And we're adding the 1/4 plus the 3/4. And this would give me the 5 plus 4/4, which then would give me an answer of 6. So going ahead and moving through that, some other pieces, that's the long version of it. I can also recognize that 1/4 plus 3/4 is going to give me a whole. So then 5 plus 1 whole is going to give me that 1. And 5 plus 1, in fact, does give me 6. So that's a really nice way of checking our work. And then we can box in the answer of x is equal to 5 1/4. Now I know that fractions aren't something that we often like to work with, but in certain situations, fractions are going to be the best use of how we go about this. We probably don't want to move along with decimals. So keep these in fraction form and let's continue working and improving our fraction skills. So example number 7 is going to be x plus 4x, or excuse me, 1/2 x plus 4x equal to 2. And I can go ahead and simplify this by saying 4 plus 1/2 is 4.5 x equal to 2. So 4.5 x equal to 2, my original operation is multiplication, so I would go ahead and divide. Before I go ahead and divide by 4.5, I want to make this into an improper fraction, and I would do that by having 4 times 2 and then adding the 1. That would give me a new numerator of 9/2. X equal to 2. Now, when we divide by fractions, it's the same thing as multiplying by its reciprocal. So if I want to divide 9/2, I really want to multiply both sides by 2/9. So let's go ahead and do that. And so we're multiplying by the reciprocal. Lucky for us, 2 times 9 is 18, and 9 times 2 is 18. And 18 over 18 is, in fact, this guy right here, reduces to 18 over 18, which is the same thing as just 1, which we really like that idea. So that's good news for us when we can go ahead and cancel those pieces out. So let's do that. And we get x is equal to 4/9 because this whole 2 is like 2/1. So 2 times 2 is 4, and 1 times 9 is 9. Let's go ahead and check our answer to see how we did on this. So our check is going to be rewriting the exact original equation. And then we're going to want to plug in and substitute our question we'll answer. We're not sure if our solution is correct. So rewriting 1/2 x plus 4x equals 2. And then plugging in where we see x, the 4/9. So 1/2 times 4/9 plus 4 times 4/9 equals 2. Now we can take a look and recall that when we multiply fractions, and in this situation we are multiplying fractions right here and right here. So when we multiply by fractions, we really want to look to cross-cancel. So when we take a look at that cross-canceling, 1 and 9 have nothing in common, and again I'm on this first one here, but 2 and 4 do have something in common. And I can cancel, there's 1, 2, and 2, and 2 2's in the 4. And similarly, on this one over here, I can notice that the whole number of 4 is the same thing as 4/1. And I actually can't cancel anything out. So I'm going to multiply 4 times 4, and 1 times 9 to get 16 over 9. Here I'm running out of room on my sheet, so I'm going to draw an arrow. Hopefully you have room on yours. So you can just continue to work vertically. So in this case, when I continue to work through, I have 2 over 9 plus 16 over 9 equals 2. And that gives me 18 over 9 equals 2 because I'm adding the numerator of 2 plus 16. And 18 over 9 does reduce to a whole number of 2. So we're in good shape. We've now checked our answer. We had a nice double check. And we're going to go ahead and box in our answer of 4 over 9. Let's go ahead and take a look at another example working with some pieces with perhaps maybe not fractions to start with, but perhaps a fractional answer. So what if we had a situation for example 8? And with example 8, we're going to start with the idea of 10x plus 8x equals 15. Now here we can go ahead and simplify to start, and we can combine some terms together. So we can only combine terms on each side of the equal sign. So I'm going to take the 10x plus the 8x, and I'm going to end up with 18x. And it's going to equal 15. Now in this case, since I've simplified, I still have a one-step equation happening, and my original equation in this situation, the original operation is multiplication. So I'm multiplying that 18 times the x, the thing that I don't know. So the inverse of multiplication is division. I'm going to divide both sides by 18. So once I do that, I'm going to be able to cancel the 18 over 18 and give myself 1x. And I'm going to see that 15 over 18 is something I can also reduce in a fractional form by 3, and that would give me 5 over 6. So let's check this answer of 5 over 6 into our original equation of 10x plus 8x equals 15, and then substitute in our suspected solution of 5 over 6 as our answer for x. So let's say 10 times 5 over 6 plus 8 times 5 over 6 and equals 15. Now in class I did discuss that idea of making sure that the check is actually happening. You know, I discussed briefly about don't phone in your check. Actually solve using order of operations. So this is a great example of when I know the answer should be 15 if we did our math correctly, but I really want to check it out. So if I do this, let's go ahead and simplify this multiplication of two fractions together, because 10 is the same thing as 10 over 1. And I can notice that the 10 and the 6 can cross cancel. So that is going to be, I can divide both of those by 2. So there are 5 2's in 10, and there are 3 2's in 6. And then I'm also going to do the same for the other side. It looks like the 8 and the 6 can also be reduced. So in this case, let's go ahead and show that reduction and multiply across. So I can cross multiply here, and there are 5 2's again in that 10 and 3 2's in the 6. So 5 times 5 is 25, and 1 times 3 is 3. The next thing I'm going to do is take a look at this fraction right here, the two fractions that are being multiplied together, and look to cross cancel. The 8 and the 6 have a 2 in common. There are 4 2's in the 8 and 3 2's in the 6. We'll multiply straight across and go 4 times 5. We'll back up a little bit there. 4 times 5 is 20, and 1 times 3 is 3. That's going to equal 15. Now, when I take a look at this, I still want to continue through, and I have common denominators, thankfully, when I'm going ahead to add these. So this is excellent. And I am going to write out that I have an LCD here. So my LCD is 3. I didn't have to do anything to change it, but that's what it is. And we're going to then we're going to add the numerators together. So 25 plus 20 is 45, and leave that denominator the same. So we'll have 45 over 3, and it will equal 15. 45 divided by 3 does in fact equal 15. Thankfully, our check does work out. So don't phone this in, guys. Make sure that you actually solve it. This is going through all the information that we've been working on with fraction operations. It's also been going on making sure that we're recognizing the same pieces on combining like terms. So if we were to make a mistake, it could possibly be in the combining like terms or in this check when we're actually messing around with these fractions. So these are important skills that we want to continue working on. Now, number 9 for an example, we're going to have a fraction of 3 over 5, y, equals -4. Now, in this case, we've got 3 over 5y. What's happening is it's being multiplied to that y. That's my original operation. I have nothing that I can simplify on either side of this equal sign, so I can skip that first step and go down to the identifying the original operation. And its inverse is going to be dividing. Now, when I divide fractions, it's the same thing as multiplying by the reciprocal. So I can multiply by 5 over 3 on both sides. And we're going to go ahead and find out that 15 over 15 is 1. So those cancel out, actually. So let's go ahead and cancel those for this fraction right here. And we're going to multiply straight across on the previous and get -20 over 3. So we think our answer is -20 over 3. Let's go ahead and check this out. Going ahead and writing the original equation of 3/5 y equals -4. And then substituting in our value we think y is. When we think y is -20 over 3. So let's go ahead and substitute that in and then simplify using order of operations. So we can, in fact, cancel the 3's, which is great. And then we're going to notice we can also cancel the 5 and the -20 as well. This is going to give me -4 over 1, which reduces to -4. This gives us the check we want, and we can go ahead and box in our answer. Now we have a couple to try on your own. So let's move to the back side so we can have some space to try on our own. Pardon me, we have one more example to go through. We'll do example number 10 together, and then you have 2 on your own. So example number 10 says -7 over 8m is equal to 1/4. And if I too quickly switched away from example number 9, please pause the video and rewind it so you can get the last bit of example number 9. Let's go ahead and take a look. We have nothing that we can simplify on either side of the equation. So we're going to identify the original operation as multiplying. So the m is being multiplied by -7 over 8. We're going to want to divide both sides by that fraction, which is the same thing as multiplying by its reciprocal. Now do be careful. We have this -7 over 8, and it kind of looks like if I was to plug in 8 over 7 that I multiply by that reciprocal, it kind of looks like we need to add in that -2. And it also, with this subtraction symbol right here, it sort of looks like subtraction as opposed to a negative. So be really, really careful when we work with this. Maybe use parentheses to remind yourselves, hey, I am working on multiplying here. Okay, so now we've taken care of that. We have now canceled out the fraction in front of m because those both cancel. And I also want you to be really careful with that negative. That negative also cancels because a negative times a negative, in fact, is a positive. So I do get -m, or I get positive m. And that's going to continue when we look at the other side of the equal sign, so when we're over here now. And we take a look at 1/4 and the -8 over 7, and we can cancel the 4 and the -8. to give us a 1 and a negative 2. So our answer for m we think is negative 2 over 7. So let's go ahead and check that out. Writing our original equation of negative 7xm times m equals 1/4. And we're going to plug in that exact answer of negative 2 over 7. Now the 7's can cancel out. We get a 1 and a negative 1. And the negative 2 and the 8 also can cancel because we have a 2 in common with both of those. This gives me a positive 1 over 4, which is what we wanted to see as 1/4. So it does check out and we can box in our answer. We're going to try these two other problems on your own. So number 11 is negative 35 equals negative 15p. And number 12 is 2/3 x equals negative 24. Be sure to check these answers on your own, and we'll also double check these in class tomorrow. Thanks for your attention.